Hello everyone, and welcome to Debonair Cyber. My name is Devin, and in today's video we're going to be continuing down the intro to Red Team track in Hack the Box. In this machine called Driver, we'll be working on uploading a shell command file that will lead into some offline password cracking, and finally we'll be exploiting some printed drivers for the privilege escalation. I'm really excited about it and I hope you are. Let's get into it. Okay, and with all that out of the way, I think we're ready to get started. We're going to come over here, got our machine pulled up called Driver. We're going to click to copy our target IP address and bring that into our virtual machine. First thing we need to do though is make sure that we have connectivity with the environment. So I'm going to cd into my Hack the Box and VPN directories, sudo openvpn into my lab file there, and you can download yours from Hack the Box if you don't already have it. We're going to enter that sudo password real quick, and we can see confirmation in the top right. Our internal IP will display there, and then we can open a new tab here, back out and make a new folder structure for this box in particular so that we can stay organized. We're going to make use the P flag to make multiple directories at the same time, and we're going to do driver and nmap, and we'll drill down into both of those. We'll kick off a quick nmap scan here, all ports, using the T flag to make that a little bit faster, no pings, and we'll paste in that IP, and we're going to let this run for a minute. Alright, so we got the scan results back pretty quick. We can see here we've got port 80 open for sure, 135 for your remote procedure call, SMB is open, and then we have some WinRM open as well. So another thing that we can do now is drill into those specifically. So we can do sudo nmap, specify those ports real quick, 135, 445, and 5985. We want some normal scripts, service detections, and we want to output that to all file types. We're going to call this driver, and once again paste in that IP. We're going to enter that sudo password and let that run for a minute. Alright, we got those nmap scan results back, and we can see here we're running a Microsoft IIS server here, so we know this is the Windows box for sure. 401 unauthorized firmware update center, please enter password for admin. Okay, so we're leaking the username here. Let's see, RPC, we can see nothing from SMB here just yet. Alright, I don't see anything else really interesting here in these results, so let's go see what's going on that that web server. We can put the IP in here, and remember, we've already got the username. We know the username is admin, and since we're already that far, we might as well try the most common default credentials of admin and see what that gets us. It looks like that was actually it. So now that we're on here, we can poke around for a couple minutes. Okay, so we can see we land here on this firmware updates page. I'm going to make this a little bit bigger for you. Select printer model and upload the respective firmware update to our file share. Our testing team will review the uploads manually and initiate the testing soon. Okay, so this sounds like they're going to, on the back end, be reviewing our file. So we know that we have some kind of user interaction going on there. So if we were to come over here to Google and search for SMB file upload attack or something similar to that. So if you were to poke around for a little bit on those search parameters, you'd eventually land on this SMB share SCF file attacks. And if you're paying attention in the intro, we kind of spoiled this a little bit, but we can see here we get this SCF shell command files that can be used to perform a limited set of operations, such as showing Windows Desktop or opening Windows Explorer. It can also be used to access specific UNC path, which allows penetration tester to build an attack. So it looks like we would be able to put in our own IP here and get a callback from the SMB share. This article also lays out, if you aren't already aware, that we can run responder when we're getting a callback from SMB, and we can actually pick up on the hash of the user that attempts to authenticate to our SMB share. So with all the research out of the way, let's start putting together our attack. So we know that we need to copy this into a file, and then we need to change these X's into our internal IP address. Remember, if you're in Cali, you can look up in the top right. Mine is 10.10.14.12. And then it really doesn't matter for the rest of the stuff. We can kind of put anything here. We can leave this as is, and we want to save this as a file. We can put this into the folder we made earlier. And as long as this has the file extension SCF, we're okay. We name it anything, so we could call it shell.scf. We'll save that. And before we go back over here and upload it, we need to set up a responder. Now back out of this, sudo responder, and we can use the H flag to get our help menu here. So when we run responder, we do need to specify with the capital I flag what interface we want to actually have this serve on. Now, if you aren't sure, you can make a new tab here and hit ifconfig. And we can see here that our ton 0 is that 10.10.14.12. Again, up in the top right if you're in Cali. As long as these two match, this is the interface. You could also just put in that IP if you wanted to, but it's a lot easier to type out the command just with the ton 0. So with all that done, then the command will just look like sudo responder I ton 0. And we do want to come back up here and make sure that the SMB server is on. That's the one that is going to be most important to us. We can leave all the others as default. So now we are actually listening for events. So we'll come back over here and browse. And we need to go to our home, HTTP driver, and upload this shell.scf file. And we'll submit that. Come back over, and we can see here that this guy is just spamming this file over and over and over again. But the important thing is we did capture this hash. So what we want to do now is copy that, and we want to put it into a new file. And we can save this as, see, we have the user Tony here. So we can save this as tony.hash. And now we can use one of our favorite tools called Hashcat to attempt to crack this. But I can hear you asking now, how do we know what kind of hash this is? So if you don't know that, you can actually come over to a new tab once again and use hash ID and use it against that file that we just created. And this will tell you it's analyzing and that it comes up against NTLM v2. And you could Google search on that to see that we come out with hashcat mode 5600. And we want tony.hash, and we'll run that against RockU. And we'll wait for that to come back. Okay, so not too terribly long there, thankfully. We can see that we did crack this hash, and the password is Lil Tony. So once again, we can put these into a new file. Echo Tony, Lil Tony. And we can write that to tony.creds. That way we don't ever lose these. We have those for our notes and all that good stuff. So now, where do we go from here? So now that we have valid credentials, we can go ahead and test those against the server to make sure that we did all this correctly. I want to use netexec for this, SMB, and we can use the user flag, Tony, and password, Lil Tony. Actually, with the IP needs to go back up here. We want to be 10.10.11.106. And we want to see if we can get some shares back. Okay, so we can see that we do actually successfully authenticate here, but that we do not have any shares that we can read. Luckily, netexec can do all kinds of fun things. And if we were to hit the help command on this, we can see that we can also authenticate through any of these file types, any of these services, excuse me. Since we know that WinRM is open on this box as well, let's try that. Netexec WinRM, and then we'll do the IP 160 and user Tony, password Lil Tony. Okay, so we try that against the WinRM service 106. I think I made a typo there. And we do see that we can actually get a shell on the machine with WinRM. One of my favorite tools to do this with is Evil WinRM. So we can go ahead, Evil WinRM. We need to specify the IP address. Let's get it correct this time. 10.10.11.106. You, Tony, password Lil Tony. And we can see we're on the box. We want to CD over into the desktop. You can get your user.txt flag right there. Okay, so now that we have a basic shell on the machine, another thing that we can do to start enumerating this box is upgrade this access into a interpreter shell for Metasploit. That way we can use the powerful interpreter shell to do a little bit of enumeration for us. We would have access to all kinds of other tools there. Just generally great upgrade to the shell that we have right now. So we need to actually generate a payload so that we can send a reverse shell back to Metasploit. And we can do that with MSF Venom. We're going to set the payload to Windows Interpreter reverse TCP. We need to set the local host to our own IP, in my case 10.10.14.12. Again, top right if you need it. Set the local port. I'm going to do 8443. And we need to specify what type of file we need to output. In this case, we're going to use an exe, and we're going to write that to a file, msf.exe. And we can see that command goes through successfully. We can ls and see our msf.exe here. Wonderful thing about WinRM is that we can go into I went through anyway. And we can go into menu. Almost fat fingered it again. And we can see here that we can actually upload that file directly from WinRM without having to do any of the other file transfer type methods. So we can upload msf.exe. We can see that we've got that right there on the desktop. Probably not the stealthiest way to do that, but it works. And now we need to start up an MSF console on our attack box. And I like to use the Q flag so that we don't get the big banner pop up. All right, that takes a couple seconds sometimes, but now we can use exploit multi-handler. we can set our payload to Windows interpreter and reverse TCP set. Well, actually, let's see what our options are. What else do we need? We do need to change the L host and L port because of what we set up, or at least what I set up in the MSF file, which is up here. So I can see here that I set L host to my IP here, and L port, which we could also once again use the ton0 interface if you wanted to do that, and I need also to put in the 8443 that I specified there. So set L host to ton0, set L port to 8443, and we're going to run that. And we can see that we started that reverse TCP handler. And then we want to execute this msf.exe. And we can see now that we're sending that stage and that we have an interpreter session. So immediately, pretty much once we get this, we want to background that session. So now, if you weren't aware, Metasploit actually has an exploit suggester. So we could search for exploit suggester, and we can see here post multi-recon local exploit suggester, and from here we can just use 0, really easy, and it'll automatically do that for us, and we can see what our options are. So this is asking us for a session that is required. And show description currently is false. It displays a detailed description for the available exploits. If you want to set that to true, you can. Otherwise, we need to set session to session 1 because that is the one that it tells us up here, session 1. You could also, if you needed to figure out which one, sessions, and it'll say, okay, ID 1, interpreter, Windows, all that good stuff. So from here, we'll set session 1. So you can see here that we got some exploits back that it appears to be vulnerable to, some printer daemon stuff that we could look into. But we can also see that this was interrupted by the console user despite me not actually doing anything. This failed because I forgot to do something somewhat important. So if we go into sessions and 1, that'll put us back into our interpreter shell, and I need to actually list out the processes and find a process with the 1 set, meaning that this is an interactive process, and then migrate my interpreter session into that interactive process. So we can use the command migrate, and we want to use this process ID, 4392 in my case. Yours will probably be different. So now, once again, we'll background and run this exploit suggester and see if we can get all of these results back. Okay, so this time the output looks a little bit different. We can see here while we ran this, and we get something similar off the front end. And then we get these other Rico drivers, token magic, and then it will actually list out in a similar fashion if we were to search all of these other exploits that it would be vulnerable to, along with the ones that it cannot reliably test for. So now that we've collected all of this information, we could go through this list and just manually exploit each one of these and see which one might be able to give us a root shell. Or we could do a little bit more recon and see if we could find some type of clue on this machine as to what the intended path is actually. And now that we're here, we can go in and see if we can search through the PowerShell history to see if we might be able to figure out some kind of, to see if we can find any kind of way forward. So now we just want to search for PowerShell history. Okay, so we should be able to copy this directory here and go back over to our evil WinRM, and you can see I've already done this here, but echo that environment variable to find out that the app data roaming Microsoft Windows PowerShell PS read line, and then we can just CD, we can copy that and CD over into there. Hit a LS, and then we can cat out the console host history. We can see here our big clue, Rico PCL6 driver name, Rico universal drivers. So go back over to our output from our tool here, and we can see that one of these exploits is a Rico driver privilege escalation. So that corresponds with 9. So we can background this. I'm already in a interpreter session, so background the interpreter if you're in there, and then we can use 9. Uh-oh, it lost our number there, so we'll have to go back up and copy this. So we can just use that. There we go, and options. So we'll set session 1 because we haven't changed it. Set L host to ton 0 and set L port to 8443. And let's run. Okay, so we can see here that after I tried to run this one, the exploit aborted due to failure, bad config. The payload should use the same architecture as the target driver. Okay, so all we had to do to fix that was go in here and set the payload to Windows x64 interpreter reverse TCP. So we needed to specify this x64 architecture for the payload to get that exploit to run successfully. And as you can see with the get UID command, we are running now as the NT authority system account. So we could drop into a shell here, and then from here you can CD into C users administrator. Maybe I can spell it right this time. Desktop. And dir, and you can see here that there is your root.txt. Alright, and with all that, I think that's going to be the end of this video. I really enjoy this box a lot. It kind of digs a little bit deeper and builds upon the basics of Windows enumeration and privilege escalation, and in this case you get to use a little bit of Mesploit as well, which I think is really fun. If you're enjoying the content here, as always, please don't forget to like and subscribe, and I'll see you in the next one.